Good morning to all. Today we are discussing about diode transistor logic. In the last class we discussed about DCTL logic. That DCTL logic have current hogging problem. Okay, so we are overcome all these disadvantages. Today we are discuss the diode transistor logic. Okay, introduction. The circuit of DTL consists of diodes and transistors. Figure shows the circuit of a two-input DTL NAND gate. It means that the diode transistor logic consisting of diodes and transistors, and here we are discuss the two-input DTL NAND gate. Okay, so this is the two-input DTL NAND gate. For example, we want to design the 4-input DTL NAND gate. So here other two diodes are connected parallel to these two diodes D1 and D2. Okay, so with respect to that, here we got the 4-input DTL NAND gate. Okay, and now we are discussing the working operation of two-input DTL NAND gate. Okay, and coming to the operation, when the transistors operates in saturation, the output voltage Y equal to logic 0 state, and when it operates in cutoff, and the output voltage Y equal to logic 1. Okay, and here we are discussing the two input side. Therefore, we got the four possible combinations. Okay, and the first possible combination is both the inputs are logic 0 inputs. Okay, at that time when both the inputs are in logic 0, the input diodes are forward biased. So transistor will working cutoff mode and the output voltage is in logic 1 state. It means that in this circuit we are giving the both the inputs are 0 0. At that time these two diodes D1 and D2 are in forward biased. Therefore here we got the output equal to 0. At that time, this D3 and D4 diodes are in reverse biased. Therefore, this corresponding resultant output is given to input of this transistor Q1. It means that when we are get this input is 0, at the time these two diodes D3 and D4 are in reverse biased. Therefore, the sufficient voltage is not given to input of this Q1 transistor. Therefore, this Q1 transistor is operate in the cutoff region. Therefore, this transistor Q1 is act as open switch. Okay, so at that time there exists a conducting path from the VCC to output terminal. Okay, now here we are drawing the equivalent circuit of both inputs are in logic 0. Okay, and the next possible combination is when any one of the inputs is in logic 1, the corresponding diodes is forward biased. So the transistor operates in cutoff and the output voltage is in logic 1 state. It means that, for example, here we are consider both the inputs. Okay, one input is logic 0 and the other input is logic 1. Okay, and when we are applying the logic 1 is input, okay, that corresponding diode is operate in the reverse bias condition. Therefore, this diode is act as open switch. Okay, and with respect to this input, here we get the output equal to logic 0. That logic 0 is given to input of the diode D3 and D4. So these two diodes are operate in the cutoff region, and these two diodes D3 and D4 is act as open switch. Okay, therefore here the output of the D4 diode is logic 0. That logic 0 is given to input of the Q1 transistor. It means that the sufficient voltage is not given to input of the Q1 transistor. It means that Q1 transistor is operate in the cutoff region. Therefore, this Q1 transistor is act as open switch. Okay, so in this circuit there exists a conducting path from VCC to output. Therefore, in this condition also we got the output equal to logic 1. Okay, and the next possible combination of inputs is when both the inputs are in logic 1, the input diodes are reverse biased. So transistor will working in saturation mode and the output voltage is in logic 0 state. It means that here we are giving both the inputs are in logic 1 state. At that time, these two diodes are in operate in the reverse bias condition. Okay, so here exists a one path from VCC to this diodes are D3 and D4. Therefore, these two diodes are operate in the saturation condition. Okay, that is we are considering the forward bias condition. Okay, so here we got the output equal to logic 1. That logic 1 is given to input of the this Q1 transistor. Therefore, this Q1 transistor is operate in the saturation region. Therefore, this transistor Q1 is act as closure switch. Okay, so here there exists a conducting path from output terminal to the ground. Therefore, here we get the output Y equal to logic 0. Okay, with respect to these input possible combinations, now we are draw the truth table of the this detail NAND gate. Okay, coming to the truth table, here we are consider the inputs and here we are consider the diodes. Okay, and here we are consider the transistor Q1 and here we are consider the output Y. Okay, and here the first possible combination of input is both the inputs are 0 0. At the time the diode D1 and D2 are in forward bias condition and the transistor Q1 is acting in cutoff mode. Therefore, we get the output Y equal to logic 1. Okay, and the next possible combination of input is one input is A equal to 1 and B equal to 0. At that time, the diode D1 is operating the reverse bias condition and the D2 is also operating the forward bias condition. At that time, this transistor Q1 is operating cutoff mode. Therefore, here we add the output Y equal to logic 1. And the last possible combination of input is both the inputs are in high. Okay, at that time, the diode D1 and D2 is operating the reverse bias condition and the transistor Q1 is acting in saturation mode. Therefore, here we got the output Y equal to logic 0. Okay, and according to our convenient point of view, here we are draw the truth table of the NAND gate. Okay, here A comma B are the inputs and Y is the output. Okay, and in this way we are designing the two input detail NAND gate. Okay, and next we are discussing the two input detail NOR gate. Okay, the circuit diagram of the two input detail NOR gate as shown in figure. Okay, and here we are using the two diodes and one transistor, and here we are collecting the output. Okay, and next we are discussing the operation of the this NOR gate. Okay, coming to the operation, when the transistor operates in saturation, the output voltage Y equal to logic 0, and when it operates in cutoff, the output voltage Y equal to logic 1. Okay, and here we are consider the first possible combination of input is both the inputs are in logic 0. Okay, that is when both the inputs are in logic 0, the input diodes are reverse biased. So transistor will work in cutoff mode and the output voltage is in logic 1 state. It means that here we are consider two diodes. Okay, the inputs of these two diodes are 0 0. At the time these two diodes are operating the reverse bias condition. Therefore, these two diodes can act as an open switch. Okay, and here we got the output equal to logic 0. Clear? Therefore, this logic 0 is not sufficient voltage to operate this Q transistor. Therefore, the transistor Q is operating the cutoff mode. Therefore, this Q transistor is act as open switch. But in this circuit, there exists a conducting path from VCC to output terminal. Therefore, we got the output Y equal to logic 1. Okay, and the next possible combination of input is when any one of the inputs is in logic 1, the corresponding diode is forward biased. So the transistor operate in saturation and the output voltage is in logic 0 state. It means that here we are considered the one possible combination of input is A is 1 and B equal to 0. Therefore, this diode D1 is operating the forward bias condition and the D2 diode is operating the reverse bias condition. Therefore, here we got the output is a logic 1. That logic 1 is given to the base terminal of this Q transistor. Therefore, this Q transistor is operating the saturation region. Therefore, this transistor is act as a closure switch. Therefore, here there exists a conducting path from output terminal Y to ground. Therefore, here we got the output Y equal to logic 0. Okay, and next possible combination of input is when both the inputs are in logic 1, the input diodes are forward biased. So transistor will working saturation mode and the output voltage is in logic 0 state. It means that here we are considered both the inputs are logic 1. At the time these two diodes D1 and D2 is operating the saturation. No, here we are considered the forward bias condition. Therefore, here we are considered the output equal to logic 1. Okay, and that logic 1 is given to input of this transistor Q. Therefore, this transistor Q is operating the saturation region. Therefore, this transistor Q is act as a closed switch. Okay, so here there exists a conducting path from output terminal Y to ground, and finally we got the output Y equal to 0. Clear? And now we are drawing the truth table of the two input NOR gate. Okay, and here we are considered the inputs A and B, and the diodes DA and DB we are considered, and we are considered transistor Q, and here we got the output Y. Okay, coming to the first possible combination of input is both the inputs are 0 0. At that time, the diode DA and DB is acting in reverse bias condition. Okay, and the transistor Q is operating in the cutoff mode, and we got the output Y equal to logic 1. Okay, and here we are considered the another possible combination is A equal to 1 and B equal to 0. At that time, this DA diode is in forward bias condition and the diode DB is in reverse bias condition. Therefore, the transistor Q is in operating the saturation mode, and then we got the output Y equal to logic 0. Okay, and here the one more possible combination of inputs is logic 1 is applied to these two inputs. Okay, at that time these two diodes DA and DB is operating the forward bias condition, and the transistor Q is operating saturation region. Therefore, here we got the output Y equal to logic 0. Okay, according to our convenient point of view, here we are redrawing the truth table of this two input DTL NOR gate. Okay, and here we are considered the inputs are A and B, and here we got the output Y equal to 1 0 0 0. Okay, and in this way we are designing the NAND and NOR logic by using the diode transistor logic. Okay, and next we are discussing the advantage and disadvantage of the DTL logic. Okay, and coming to the advantage. Okay, the advantage of the DTL logic is relatively large fan out. Okay, and next we are discussing the disadvantage of the DTL logic. Okay, and first disadvantage is large area is needed for the input diodes, and second one a relatively large power dissipation, and third one is slow transition time, and fourth one is the long propagation delay. Okay, and these are the disadvantages of the DTL logic. Okay, thank you.